Hey everybody, it's Grace here. Today we are on lesson 10 and we're going to be covering converting bases. All right, so we're going to start with decimal to binary conversion. Now let's talk about each of these bases first. So first of all, let's discuss the decimal base. Now, this is the base that we use to represent our numbers usually. So, for instance, we could have something like 59. And this is in the decimal base. Why is that? Because if we take a look at the place value of every digit, it's a power of 10. So the place value of the units digit is 10 to the power of 0. And then the place value of the digit 5 is 10 to the power of 1. And so the root for 10 is deca or dec. And since everything here is always base 10, we call this the decimal system. Okay, so now for the binary system, a number in binary might look like this. And maybe you've seen something like this before. It's basically just a bunch of ones and zeros. And then if we want to, usually when we are writing numbers in a base other than 10, we're going to specify that by adding this little subscript with the number that represents our base. So binary is basically base 2, and that is our subscript here. Okay, so now if we take a look at the place values, let's start with the rightmost digit, 1. The place value here is 2 to the power of 0. Here it's 2 to the power of 1, then 2 to the power of 2, and 2 to the power of 3, and so on. By now you should be able to see a pattern. So now here, where everything was base 10, here everything is base 2. It's always 2 to the power of something for the value of each digit. And so the root for 2 is bi. So we call this the binary system. All right. And so you might be wondering, why do we need to know the binary system and why so much math? Binary system is super important to computers. That's basically what runs underneath. So it's important that we as programmers also understand how this binary system works. All right, so by now you should have a pretty basic understanding of the decimal and the binary system. So then let's talk about how we can convert these values. Okay, so let's say the decimal number I have is 22. And so this is in decimal, and now I want to convert it to a binary number. So it's going to be equal to something base 2. All right, so there's two methods you can go about this. One is a slower way, the other one is the quicker way. So let's kind of talk about the slower way first. So here, what you're going to do is kind of count up to the greatest power of 2 that can fit in our decimal number. So in this case, it's 22. Now think about it. What's the greatest power of 2 that fits in 22? Well, let's just start by writing blanks for each digit in the binary representation of 22. So here, 2 to the power of 0, that's 1. That definitely fits. 2 to the power of 1, 2, that definitely fits in 22. 2 to the power of 2, 4. 2 to the power of 3. And then we can stop at 2 to the power of 4. This is equal to 16. This is the greatest power of 2 that's going to fit in 22. All right, so now we're going to go from left to right and fill in each of these digits. Okay, so as we go from left to right, we just want to count how many times of the current place value or the current power of 2 fits inside of 22. So 2 to the power of 4 fits in 1 time. All right, but now what we're going to do is subtract its value from 2 to the power of 4. Sorry, we're going to subtract its value from 22. And this is equal to 6. So here we already have 16 taken care of. Now we still need to distribute the 6. All right, next up, 2 to the power of 3. That is 8. 8 doesn't fit in 6 at all, so we're just gonna put a 0 here. Now for 2 to the power of 2, this is equal to 4, which fits into 6 exactly 1 time. All right, so now let's update 22 and subtract 2 to the power of 2 from it. So 6 minus 4. All right, now we have to distribute 2. Okay, next place. 2 to the power of 1 is exactly equal to 2. So we can fit it in once. And then let's subtract this. What we have remaining is just a 0. So when we get to the very last digit, without being said, a 0 goes here. Okay, and so this is 22's binary representation. So 22 is equal to 1, 0, 1, 1, 0, base 2. Okay, take a quick few seconds to look over this and see if it makes sense to you. All right, so what we've just covered is a kind of more guess and check method, and it can be quite tedious, especially if your decimal number is really huge. So what's a faster way to do this? Well, there is a nice trick that allows us to convert a decimal number to a binary number pretty efficiently. So let's still use the number 22. And it's equal to some number in base 2, which we already found previously, but let's just keep this number for example. So the first step we're going to take is divide 22 by 2. All right, well, it fits in 11 times and it has a remainder of 0. And so this remainder, I'm going to kind of keep it out here because I'm going to want to save this 0 for when I form my number in base 2. All right, so then I'm going to take the quotient from the previous division, which is 11, and then divide it by 2. Then I get 5. But here my remainder is 1. Okay, now I take 5 and I divide it by 2. I get a quotient of 2 and then a remainder of 1. Then I take 5 Then I take 2 divided by 2 and I get 1. With a remainder of 0. Finally, I'm going to take 1 divided by 2. I get 0 with the remainder of 1. All right, and so once I hit a quotient of 0, I'm going to stop because it makes sense. If you take 0 divided by 2, you're going to get 0 again, and so on. And there's no need to do that. So we reach a quotient of 0, we can stop. All right, so then let's take a look at our remainders here that we have on our right side. We're going to string them together from the bottom to the top. So then this will give us 1, 0, 1, 1, 0. And look, this is our binary number. This is what we found earlier. So there we have our answer. And it was a lot easier. All we had to do was divide. We didn't have to do all the subtraction and multiplying and that kind of stuff. So once again, take a few seconds, look at it, and see if you understand the concept. All right, so now we have understood the math behind converting a decimal number to a binary number, which is super important in a problem like this. Then we're going to write a program that converts a decimal number to a binary number. So recall that we just learned 2 methods of doing this. So think about it to yourself and ask yourself which method you think would be more efficient or easier to implement in code. The first one where we kind of had to find the highest power and then check every single place value and see if it fit inside the decimal number and then subtract, or the other one where we just did repeated division and then took the remainders and strung them together. Okay, if you were thinking the latter method, then you are correct. So that's exactly what we're going to do. We're just going to do repeated division and then store the remainder somewhere. All right, if you haven't already, let's hop on to Replit and create a new program. Let's import the scanner so we can read input. Okay, so what we want to do first is read in a decimal number. And so we're just going to store that in some integer called n. All right. Now let's create a string to store the binary number. And actually, you might want to rename n to dec, short for decimal. So this is more clear what we're doing. Okay, so here we're going to use a similar algorithm to where we were trying to calculate the sum of the digits of some number. Maybe you guys remember that, maybe you don't, but here's a quick refresher. So basically, we have some number we want to calculate the sum of the digits of, and then we set up a while loop where the condition is that that number is greater than 0. And so inside the while loop, we get the rightmost digit, and then we update the number by dividing it by 10. So perhaps that rings a bell to you guys. If it doesn't, no worries. It's super simple. We'll just go over it again as we write this program. Okay. So inside our while loop, we're gonna get rather than getting the rightmost digit, what we're gonna do is find the remainder when we divide the decimal number by 2. So let's call this digit, and it's going to be equal to dec. And here we're going to use the modulus operator, since this gives us the remainder when we divide the first number by the second number. So yes, the digit is equal to the remainder of the decimal number modulus 2. Okay, then what we're going to do is add this digit to our binary string, because this is what goes in our output, and we're trying to form the output right now. So let's add digit 1. All right. Now, next step, we have to update the decimal number, else this while loop is never going to terminate. So how we're going to do that is divide it by 2. Now, you might be wondering, why didn't we put this step before this step? Because that's kind of what we did when we were doing it with pen and paper, right? But here, if we divide it by 2 already, we're going to be missing that remainder that we want. We'll be skipping a step. So we have to put it after we get the remainder first. All right. So there we go. With just a couple lines, we found the binary string. But now what we have to do is print our output. So we can say the binary number is... Okay, so let's run this and test it. So I'm going to use my example with 22. All right. So let's look at our output. Maybe you guys noticed something a little strange. it looks a bit off. So instead of 10110, we get 01101. So the problem is that our output is reversed. And there's no problem with that because it's expected with the string concatenation we're doing here. But we do need to fix that problem by reversing the string once again. So after we have found our binary string, let's create a new one. Let's call it output. And this is going to be our binary string reversed. So we're going to go from right to left and then add on the current character to output. And then here we want to print out the output string instead of the binary string. Okay, let's run it and test it now. All right, so now our problem is fixed. We get the correct output string saying 10110. And there we go. We've written a program that converts a decimal number to a binary number. All right, so now what about the reverse? Now we want to do a binary to decimal conversion. So let's first talk about how we actually do this. So now for my input, I would have some binary number. Let's say it's 10110, which is equal to 22. We already know that. And then I just want to convert it to some decimal number. So now how I do this is I'm just basically going to add the place values of all the ones because zeros we don't care about. In any base, 0 times whatever is going to be equivalent to simply 0. So let's start from the right to the left. Here, this one has place value 2 to the power of 1, and then this one has place value 2 to the power of 2, and this one 2 to the power of 4. Okay, then all we gotta do is add them together. So 2 to the power of 4 plus 2 to the power of 2 plus 2 to the power of 1 gives us 22 in base 10. And there we go, there's our answer. So take a few seconds and look over this and see if it makes sense to you. All right. So once again, now that we know the math, which was pretty easy, let's try and implement this in a program that does this binary to decimal conversion. All right. So now for our input, we'll be reading in a binary number. And then let's create a variable to store our decimal number. Okay. So when we were doing this by pen and paper, it was easy for us to pick out the ones and then just add their place values. When you're writing a program, it's not so easy to do that. So instead of picking out every single one that we see, we're just going to go through all the digits. Then that requires us to know the place value of every current digit, right? So we're going to start our place value at the lowest possible, which is 2 to the power of 0 or 1. All right. Now here, we're just going to do a similar while loop to take a look at every single digit. So the binary number has to be greater than 0. And then let's get our current digit. So our digits can only be 1 and 0. And the current digit is going to be equal to the binary number modulus 10. Okay, then let's think about, okay, we have our digit now. Now, how do we update the decimal number? Well, going back to our example, if we expand this, we can actually say it's equal to 1 times 2 to the power of 4 plus 0 times 2 to the power of 3 plus 1 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 0 times 2 to the power of 0. And so our current digits, as we do this, will be 1, 0, 1, 1, and 0 once more. So I think this gives us a pretty good idea of how we'll be wanting to calculate the decimal number. So after we get the current digit, we're going to increment the decimal number by the digit times the current place value. Okay, here we're not quite done. We still have to update some variables. So first, we need to update the binary number, divide it by 10, so that we can access the next rightmost digit. Once again, this is really similar to the sum of digits algorithm that we have gone over previously. And then we also need to update the place value. We don't want it to be stuck at 1 forever. Now, if we look at the place value, it's doubled each time. So we're going to multiply the place value by 2. All right, so at the end of this while loop, we should have found the decimal number. So we're going to print out the decimal number is the value we just calculated. Okay, let's go ahead and run this. So here I'm going to use the same example I had used for explaining. So 10110. And here's my output. The decimal number is 22. All right, great job. So you've managed to write a program that converts from decimal to binary and also vice versa. So thank you so much for watching this lesson, and I will see you guys next time. Bye.